Okay, today we're going to talk about how you integrate exponential functions and functions where you're dealing with an x as an exponent of -1. Um, One that you'll see quite often is this form here, the integral of e to the x dx. Well, um, in calculus, the definition of e is e to the x is a function whose derivative is itself. And so the integral of e to the x dx is actually e to the x plus c. Just that. The derivative of e to the x, which we learned before, was just e to the x. Therefore, it's the integral of e to the x is also just e to the x, but we have to add that constant c. Now, if let's say the derivative of our exponent is different than 1, like in the case where we have like e to the ax plus b dx, that integral is going to be the same. So we're going to have e to the ax plus b. The exponent never changes. We have the plus c. But then we have to deal with the fact that we are integrating and the derivative of our exponent is different. Well, remember, when we integrate, we divide, so we're going to end up multiplying by 1 over a. Or in a sense, it's the same thing as dividing by a. But more often than not, you're going to see it written as 1 over a up front. So this is a rule that you just need to understand and know. We've learned this from derivatives before. Now, one that we haven't looked at before is the integral of 1 over x dx. Now, when we've done the power rule, we saw that like the derivative of x squared is 2x dx. And, the derivative of x is 1, right? Technically, it's 1x to the 0 dx, which we don't need the x to the 0. Well, if you had, let's say, when we look at this, the derivative of 1 is just 0. Well, how is it that we go from x to the 0 to x to the -1? How do we do that? Which is kind of our situation here. We don't know. But what we found is this general rule that looks like this. Because our power rule breaks down, the logic of the power rule breaks down right here. So this is actually an identity that says that the integral of 1 over x dx is the natural log of x plus c. So the natural log is an identity that you're going to need to know, which is the derivative of 1 over x, or anytime we have x to a negative exponent. Now our x's are going to be limited to being greater than 0 because of the way the natural log works. So this is a condition as well. Now, likewise, if we have, let's say, some sort of operator on x, like 1 over ax plus b dx, well, how this works is that we're going to, kind of just like the last example, we're going to have the natural log of ax plus b plus c, but then we have to deal with the fact that the derivative of the inside of our function is a. So we will be multiplying on the outside by 1 over a. Now, again, just like in this previous example, because we can't take the natural log of a negative number, we now have to say, well, whatever our natural log is being taken of must also be greater than 0. So this is a condition that we have to be aware of.